Take pictures. You can show because he's willing to work with you here to show you this. The Undersecretary for the Department of Energy came here, and it just didn't happen to be the right day, so he actually didn't get to see what you get to see, and he was paying for this, and you're not. Well, I guess you are as taxpayers.
It's a miniature folding robot bulldozer.
That's exactly
right.
what it is.
And that's exactly what it is.
Wow.
It's an 800-pound...
Can I get my daughter one of these for Christmas?
Oh, hey. They will not let us sign up for the BattleBots.
Oh, man. You totally wiped them.
But this thing is a monster.
Wow.
We have a lot of junk down inside of our tanks, so you get a kind of feel for it. We do have pipes that people have dropped in the tanks over the years.
Oh, geez.
Cables, wires, you name it. We studied, and we actually have spent quite a bit of money on robotic arms. And we've studied that a long time over the years. You know, wouldn't a robot come down a 12-inch? Well, think about it. Do you think you can get a robotic arm to come down that 12-inch and then go over 60 feet? And the answer is no, that's not within the limits of our current technology to be able to do that kind of thing. And yet this thing can come down and then go over 60 feet.
So the whole purpose of this thing is to push the sludge towards the place where it's getting sucked.
That's exactly right. The problem right now is, you know, rather than put a person down in there, which was what the EPA's suggestion was, we've developed a robot. So who developed this little robot for us? Well, we went out and did a worldwide search for people who clean tanks in hazardous environments.
Wow. Oh, awesome.
It's now pushing more than its own weight.
Yeah.
That's very impressive. Very impressive.
I mean, I don't think that I could push that.
And if I'm lucky, he will not turn on the sprays while he's faced us. I usually stand over by Ken because they work for him, and that way I don't get sprayed. By the way, what you just heard, the communications, it's kind of like what he's doing is giving him an instruction. They're repeating the instruction back, and then he's confirming that they got it right. That's called three-way communication. It's very, very important in our environment. So not only can it push it over, but if you really wanted to get your garage floor clean, right, you get the hose out and you would hose it off as you went. And so it's designed to have a high-pressure spray, and what you can see behind it is the paint on the original steel floor.
Huh.
See how clean that is as he's going along? It's so clean they've actually scraped some of the paint off, and now we're down to steel in some places. Our goal is to do a high-quality cleanup. You know, to do it safely, nobody gets hurt, and do a high quality on that cleanup and make that device.
Does it have a camera on board?
It could. Right now, we're not currently planning on putting a camera on board. Here's the reason. Cameras can fail.
Right.
Okay? This is actually not an easy thing to get back out of the tank.
I wouldn't imagine it would be.
Is it a sacrifice, basically?
This is a sacrifice mission. But if you look up here, you'll see that there are 3 different cameras watching us as we speak. And so we find other holes. We stick the cameras down those. And then what we do is we watch everything and manage everything from those cameras, and if they fail, we can pull them out because they've never been in the waste. This thing goes down into the waste. When you're done, no matter what you try to do, it's going to be contaminated. It's going to be waste.
It's just part of the waste.
It's just part of the waste.
So it's one per tank, basically.
Basically one per tank. This device, this one you're looking at, its long-term life is to be at the bottom of tank C109 forever. Eventually what will happen. So, yeah, what do you do with the waste on the walls?
Wow.
Crowd control, baby.
Yeah.
You could break up a frat party with that thing.
He's actually not going to the highest pressure that's possible.
I see those spots on the wall there that you open.
Yeah.
Now I understand where they came.
Yeah. We've had devices, and we had a device in a tank that goes up to 32,000 psi with the water pressure. You guys were at the presentation where I talked about that last year. At those kind of pressures, If you put just a little bit of sand in there, it'll cut right through steel very nicely. In fact, it's used commercially as a steel cutting device. We're careful to use very clean water here because clean water doesn't tend to cut steel as well, and of course our idea is not to make more holes in the steel, and so the fact is we've actually dropped our water pressure down here. And that's why BattleBots don't got a chance, because we can stand off 30 feet and actually cut them in half.
Oh my gosh.
Okay.
Wow.
So yeah, you don't want to take us on
getting water.
BattleBots.
It's getting water and control and power all down this lead.
Yes, hydraulic, and this is all hydraulically driven. Okay, now remember the environment. Highly radioactive. Okay, lethal doses in minutes if it was a person down in there. So, but you have to have materials that can take that kind of high radiation. Highly caustic. Remember, it can just eat things up, so you got to make it out of material that can survive in the caustic environment.
What are those tropes?
But here's joy just gets even better. When you put radiation and water together, what do you get? You get radiolysis, which means hydrogen and oxygen in water split and become gas.
So it's flammable.
So it's flammable and explosive as well, and so you don't want to send a lot of electrons down into that potential environment. Right?
Or do you want to send in a lot of water because you're trying to reduce the amount of waste?
There you go. So you want to keep the water to a minimum, but that's okay. We have ways to manage the water. Hydraulics. So you can get a lot of hydraulic power, as you can see, down a very small hydraulic line. You can do a lot of power transmission. So all the power is up above, and it goes into making high-pressure hydraulic fluid. And that's why you can go down a 12-inch riser, have a whole bunch of cables, hydraulic cables, no switches in here, no electrons in here. That's one of the other reasons we don't want to put a camera on it. Keep the cameras up above.
So it's all hydraulic. It's like a 68 T-Bird.
That's right. It's all hydraulics. This is all
Old
hydraulic.
T-Birds had hydraulic windows and locks.
Yes, that's right.
I'm also impressed